Hello, I'm Miss Ginsburg with KnowAtom, and today we're going to be reading Earth Materials. This is a student reader in Unit 2. Earth's Minerals. The Hope Diamond. A museum in Washington, D.C. holds the world's largest deep blue diamond. This 45-carat blue diamond is the size of a walnut. It is called the Hope Diamond. The Hope Diamond has long fascinated humans. More than 100 million people have visited the museum to see the diamond. It was first discovered in India in the 1600s, but its history goes back far beyond that. Scientists believe it is at least 1 billion years old and was formed so deep inside Earth that humans cannot travel there. How diamonds form. All diamonds are formed deep within Earth, at least 161 kilometers or 100 miles below the surface. They can only form under tremendous heat and pressure. This heat and pressure are a result of Earth's structure. The center of Earth is a solid ball of metal iron and nickel. It is called the inner core. The core is 7,000 degrees Celsius, hotter than the surface of the sun. The outer core wraps around the inner core and is made up of liquid iron and nickel. The mantle is located around the outer core. The mantle is Earth's thickest layer. Imagine an apple. The core of the apple is like the Earth's core, and the fleshy part that you eat is like the mantle. Earth's mantle is an ocean of semi-solid rock called magma. It is here where diamonds are formed. Earth's skin is its crust. The solid crust is the coolest layer of the planet that forms the continents and holds the ocean. So here's the Earth's layer, right? We've got the inner core, outer core, mantle, crust. Diamonds are minerals. Diamonds are made mostly of a single element, carbon. The heat and pressure of Earth's interior cause the carbon atoms to join together in a way that results in the unique physical properties of diamonds. Diamonds are minerals. Scientists have found more than 3,000 minerals made up of different combinations of elements. All minerals are naturally occurring, which means they are not made by humans. They would exist on Earth without people. Minerals are also inorganic because they are not the product of something that is living or was once alive. Leaves and shells are organic because they come from something that was once alive. They also have a definite chemical composition. This means that every mineral is made up of the same kind and number of atoms. For example, diamond can always be described by the chemical formula of C since it is made of carbon atoms. Lastly, minerals have an orderly crystal structure. This means their atoms are neatly organized to form a repeating pattern. So here is a diamond's crystal structure of carbon atoms. Identifying minerals. One of the reasons that people are drawn to the Hope Diamond is its color. Blue diamonds are very rare. They are blue because they have traces of the element boron combined with the carbon atoms. Diamonds come in many different colors, including red, yellow, green, purple, and brown. Color is one property that scientists use to identify minerals. In addition to color, there are many other property tests that scientists can do to identify a mineral. For example, scientists were fascinated to discover that the Hope Diamond gives off a fiery red glow after it has been exposed to ultraviolet light. This is called phosphorescence. Scientists have learned that all natural blue diamonds glow red for about 5 minutes after being exposed to UV light. However, blue diamonds created by humans give off different colors. Because of this, phosphorescence helps scientists determine whether a blue diamond is real or fake. Other diamonds do not phosphoresce. Instead, they fluoresce, which means they give off light only as long as UV light is shined on them. One of diamond's most well-known properties is its hardness. Hardness is a measure of a mineral's resistance to scratches. Mineralogists use a 1 to 10 hardness scale called the Mohs scale. Talc is a 1, which means it is very soft. Diamond, in contrast, is a 10, making it the hardest naturally occurring mineral. It is so hard that only another diamond can scratch it. Its hardness is caused by the way that the carbon atoms join together. The hardness of diamonds make them useful for different applications. For example, they are used in cutting tools for military materials such as airplane parts and armor. Most diamonds are also excellent electrical insulators. This means that they do not conduct electricity. Conductivity is tested by placing the mineral in a circuit and seeing if it conducts electricity. However, blue diamonds, such as the Hope diamond, are semiconductors. Depending on what other molecules are around, semiconductors can sometimes conduct electricity. Blue diamonds can sometimes conduct electricity because boron is a semiconductor. Diamonds are also excellent thermal conductors. This means they conduct heat. This explains why diamonds feel cold to the touch. Here, this is a blade that has diamonds in the metal. Scientists rarely rely on just one property test when they are identifying a mineral. Many minerals share some of the same physical properties, including color and hardness. However, when many of the mineral's properties are examined, it often results in a unique set of properties that can be used to correctly identify the mineral. For example, in addition to hardness and conductivity, scientists look at the mineral's luster. Luster is the way light reflects off of the surface of a mineral and how bright, dull, or greasy the mineral appears. Luster falls into two categories, metallic and non-metallic. Cut diamonds often have a metallic luster. This gives them a brilliant, freshly polished look. In contrast, uncut diamonds can have a greasy or dull luster. Pure diamonds are also the most transparent known material. Transparent substances allow light to pass through. Pure diamonds are rare, however. Some non-pure diamonds are translucent, which means they allow some light through and absorb some light. Opaque diamonds absorb all light. This diamond has a high luster because its surface reflects light. Earth's tectonic plates, erupting volcanoes. People cannot travel to Earth's interior. The deepest any machine has drilled into the planet is 12 kilometers or 7 miles. We can only see diamonds that have been carried from the mantle to Earth's surface by volcanic eruptions. Volcanoes are structured formed around a hole in Earth's crust that releases magma. Magma that reaches the surface during an eruption is called lava. Lava is liquid rock that turns into solid rock as it cools. The magma carries diamonds with it. Scientists believe that the kinds of volcanoes that brought diamonds to the surface don't occur anymore. Scientists think this is because Earth used to be much hotter. This resulted in volcanic eruptions that were very explosive. The erupting magma carried the diamonds, which had already formed, from the mantle to Earth's surface very quickly, traveling 48 to 64 kilometers or 30 to 40 miles per hour. Moving plates. Volcanoes happen because Earth's crust is broken into drifting slabs of solid rock called tectonic plates. The plates cause Earth's surface to look like a jigsaw puzzle. Heat from Earth's core causes the semi-solid rock of Earth's mantle to rise and fall like ocean tides. As magma moves beneath the crust, it pushes the tectonic plates towards or away from each other. The places where Earth's tectonic plates meet are called fault lines. Plate boundaries. The different movement of the tectonic plates change the surface of the Earth. When two plates move toward one another perpendicular to the fault line, they form a convergent boundary. When two tectonic plates collide at a convergent boundary, the force is very powerful. It can cause the land to be uplifted, forming mountain ranges and volcanoes, as well as earthquakes. Sometimes two plates move apart from one another perpendicular to the fault line. These plates form a divergent boundary. This movement can create ocean trenches, valleys, earthquakes, and places where magma wells up onto Earth's surface. Transform boundaries are formed when two plates slide past each other in parallel, grinding along their sides as they go. This motion can cause earthquakes. Convergent plate boundary, divergent plate boundary, and transform plate boundary. Active volcanoes. Sometimes the movement of the tectonic plates causes holes called vents to open up in Earth's crust. The vents allow magma from the mantle to seep through. This is how volcanoes form. Volcanoes can be active, dormant, or extinct. It depends on how close the crack in Earth's surface is to an available pool of magma in the mantle, called the magma chamber. An active volcano erupts at least once every 10,000 years. A dormant volcano hasn't erupted in the past 10,000 years, but is expected to again. An extinct volcano is expected to never erupt again. A volcano can become dormant or extinct if the movement of tectonic plates carries it away from its source of magma. Landforms patterns. The majority of landforms on Earth's surface have formed because of the movement of the tectonic plates. Because of this, mountains, valleys, and volcanoes are common at fault lines. Earthquakes are also common at fault lines. If two plates get stuck together, they build up energy until they can break apart. Earthquakes are the vibrations felt when the tectonic plates gather enough energy to move past one another. Earthquakes occur all over the world at all three kinds of plate boundaries: convergent, divergent, and transform. Volcanoes are most common along divergent and convergent boundaries. One of the most well-known plate boundaries encircles the Pacific Ocean. It is often called the Ring of Fire because so many earthquakes and volcanic activity occurs here. The Ring of Fire has more than 450 active volcanoes. Mapping patterns. Geologists use maps to make sense of the data they collect about Earth's surface. Every location has a set of two coordinates that meet at a specific point on Earth: latitude and longitude. Horizontal latitude lines mark how far a point is north or south of the equator. Vertical longitude lines mark how far a point is east or west of the prime meridian. Latitude and longitude lines help scientists identify specific locations on Earth. For example, they can use the latitude and longitude points of specific volcanoes to see whether any patterns emerge in the locations. Earth's rock. Diamonds in the rock. Diamonds are one of the world's major natural resources. Around $13 billion worth of diamonds are produced every year. Because of this, there are people around the world who search for diamonds. People who search for diamonds often look for specific kinds of rock that hold diamonds within them. This is because minerals that are pressed together form rocks. All rocks are made up of mixtures of minerals. When minerals are pressed together by the heat and pressure of Earth's interior, they can combine to form different kinds of rock. Rocks make up Earth's surface and other terrestrial objects. Scientists classify rocks based on how they are formed. There are three categories of rock: igneous, metamorphic, and sedimentary. Each category of rock has different properties that scientists can use to identify it. Igneous rock. Many diamonds are found in a kind of rock called kimberlite. Kimberlite rocks are generally only found in very old parts of Earth's crust. Kimberlite is a kind of igneous rock. Igneous rocks are often found around volcanoes because they form when hot semi-solid or liquid rock, either magma or lava, from Earth's mantle cools into solid form. The magma either cools slowly below Earth's surface or is released as lava in volcanoes. When magma spews from a volcano, it cools quickly when it is exposed to the cooler temperature of Earth's oceans or atmosphere. The cooled lava hardens into igneous rock. Rocks formed this way are fine-grained or glassy. However, not all magma erupts out of a volcano. Some magma is pushed slowly towards Earth's surface over many years. This magma will cool more slowly than magma erupting from a volcano. Igneous rocks formed this way are coarser. Categories of rock. Sedimentary rock forms from layers of sand, soil, clay, gravel, and other sediment that build up in one location over time. Sediment is a collection of particles and pieces of living and non-living things. It collects in layers over time. Over thousands of years, the pressure of more and more top layers of sediment compresses the bottom layers of sediment into solid rock. The oldest sediment forms the bottommost layer of the rock. New layers replace older layers at the top. Metamorphic rock is a category of rock formed in chemical reactions where one type of rock is changed by pressure or heat into a new type of rock with different properties. The movement of the tectonic plates can cause rocks to get pushed down deep into the crust. There, the heat and pressure of all the weight on top of it cause chemical reactions in the rock to change it into a new rock with different properties. In a chemical reaction, the molecules of a substance are rearranged into a new substance with new properties. The word metamorphose means to change or to transform. It can take millions of years for a metamorphic rock to form. The rock cycle. Rocks do not remain the same forever. The matter that makes them up is cycled and transformed into different categories over time. For example, rocks on Earth's surface break down into sediment. That sediment can collect in layers. Over time, heat and pressure can compress the layers of sediment into new sedimentary rock. Or the sediment can get pushed deep into Earth's crust by the movement of tectonic plates. There, it can undergo chemical reactions that change its properties, turning it into metamorphic rock. Eventually, any rock pushed deep into Earth's interior will melt into magma. If magma reaches the surface, it will cool and harden into rock again. The processes that form, break down, and reform rock from one category to another are called the rock cycle. So here you can see the processes of the rock cycle. Weathering rocks. All rocks on Earth's surface are broken down over time through a natural process called weathering. Weathering is the breakdown of rock into small pieces from exposure to wind, water, changes in temperature, and or biological forces. For example, when kimberlite rocks reach the surface, they are immediately weathered. Sometimes weathering wears down the rock so much that the diamond becomes exposed. There are two kinds of weathering, mechanical and chemical. Mechanical weathering takes place when rocks are broken down by physical forces without any change in their chemical structure. Mechanical weathering is a physical change because it does not affect the chemical structure of a substance. Whenever rocks and sediment grind against each other, they mechanically weather surfaces. This kind of weathering is called abrasion. Chemical weathering occurs when chemical reactions change the composition of rocks, rearranging the atoms or molecules into new substances with different properties. Chemical weathering generally occurs gradually over time. Eroding rock. Wind, water, or gravity then transports the sediment to new locations in a process called erosion. Kimberlite rocks containing diamonds have been found in areas away from volcanoes, eroded by wind, water, or gravity. Weathering and erosion usually work together. For example, wind and water carry pieces of sediment that grind against rock and wear it away. Water can also seep into cracks between rocky particles and expand, making cracks larger. Over time, the rock wears down from the inside and crumbles into sediment. Weathering and erosion are both processes that can occur rapidly or over many years. For example, it can take many years for some rocks to be broken down into smaller pieces of sediment and to then be transported through erosion to a new place. However, erosion can also occur rapidly, such as through landslides caused by flooding. Earth's systems. As water moves over rock, two of Earth's systems interact together. A system is a set of connected, interacting parts that form a more complex whole. Each system is made up of parts that influence one another. At the same time, the systems interact with each other. For example, all of the water found on Earth makes up an Earth system called the hydrosphere. Earth's landforms, including rocks and soil, are part of a system called the geosphere. As water moves over Earth's surface, it shapes the geosphere as it weathers and erodes the rocks and soil it passes over. When wind weathers and erodes rock, another system is at work. The atmosphere is the Earth system made up of a mixture of gases, dust, water vapor, and other molecules above Earth's crust. Earth's gravity holds the atmosphere in place. Another Earth system is called the biosphere. This system includes all living things on Earth. Living things depend on all of the other systems for survival. At the same time, living things impact their surroundings as they breathe air, drink water, and live on Earth's surface. Wow, I really learned a lot reading Earth materials. I hope that you learned a lot too. I'll see you tomorrow with another one. Bye.